Okay, we're in the second unit of algebra here, and we're solving some simple linear equations. So my rule for this is always, if you have letters on both sides, is to get rid of the smallest letter. So we have 2y here, but we have a minus 4y, and so that's smaller, that's a smaller number, it's lower down. So we want to try and get rid of that. So the way we would do that is to add 4y to both sides. If we add 4y to both sides, we end up with a 5 here, and we end up with a 6y minus 1. I know the y's on the wrong side, but that's okay, we can change that later. I then think we should try and get the y on its own. So we want to get rid of the 1, we want to get rid of the 6, so I'm going to add 1 to both sides. That gives me 6 equals 6y, and then hopefully most people realise we want to divide by 6 to get 1 equals y, or y equals 1, then finally written the right way around. Example 2 is the next step up from that. I think we should join together our like terms on each side first of all. So like terms here, 8f take away 2f, so we have 6f plus 3 equals 4f plus 11. And what I like about these questions is it's now in the same format as our previous question. So we just pick up where we left off in example 1. 6f and 4f, the smallest value is a 4f, so we want to get rid of that. So we're going to take away 4f from both sides. That gives me 2f plus 3 equals 11. Again, we want to eventually have an f equals down here, so we need to get rid of the 3, we need to get rid of the 2. So getting rid of the 3, we're going to take away 3 from both sides. That gives me 2f equals 8. Dividing then both sides by 2, I'm going to get f is 4. Next example then. Example equations with brackets. Again, hopefully a nice straightforward one here. We're going to get rid of our brackets first, and then we'll start to simplify. So multiplying at this bracket is going to give us 3x plus 6 minus 7 equals 2 minus 2x minus 4. I hope we're okay with that. Some people put a wee 1 in there to help us realise what's going on. Before I take away things from each side, I want to simplify and join together our like terms. So 3x minus 1, that's a 2, that's a minus 4, so you have minus 2x minus 2. Get rid of the smallest letter. We've a minus 2x, so we need to add 2x to both sides. Add 2x to this side gives me 5x minus 1 equals minus 2. I'm going to add 1 to both sides. 5x equals minus 1. I'll divide by 5. I'm going to access minus 1 over 5. Again, I hope we're comfortable that minus can come out the front or it can go to the bottom. It can't be in both. That would make it a positive. A little bit then on formula equations. So the sum of 3 consecutive odd numbers is 195. Find the number. So we need to try and use a letter to represent the unknown. So 3 consecutive odd numbers. So I'm going to go with x to be the smallest of those odd numbers. My next number then, if it's consecutive odd numbers, is x plus 2. And my next number then is x plus 4. Because if you have an odd number, the next odd number is 2 bigger, and then 2 bigger again. So that's what we have. What this says is the sum of those is 195. So we're going to go for x plus 2 plus x plus 4 is 195. And now we just did what we were doing for the previous examples. Join together our like terms. 3x plus 6 equals 195. Take away 6 from both sides gives me 3x equals 189. Divide both sides by 3. What's that going to be? 63, I think. So one of my numbers is 63. Then the next number is going to be 65, and then 67. So 63, 65, and 67. Then are the 3 numbers, and sure enough, if you add those together, you will get 195. Next one then. Let's take a look at this. Find the length of each side of this right angled triangle. So what do we know about sides of a right angled triangle? We know that Pythagoras Theorem works for those, so I wonder could we maybe solve it like that. So let's label this one A, this one B, and this one C, and we know that A squared plus B squared equals C squared. So we know that 6 squared plus x minus 1 all squared equals x plus 1 all squared. We need to multiply these out and tidy them up, so we are going to go for 36 plus x minus 1 upon x minus 1 equals x plus 1 upon x plus 1. That gives us 36 plus first x squared outer minus x inner minus x last plus 1, x squared outer plus x inner plus x last plus 1. Tidying up and joining together my like terms here. X squared minus 2x plus 37 equals x squared plus 2x plus 1. My x squareds here are going to cancel. It's a bit like taking them away from both sides. I hope you can see that. And then what I'm going to do, I'm going to, I don't know how good this looks here, but we'll do it this way anyway. I'm going to add 2x to both sides. That gets rid of the smallest value of x. So I'm going to get 37 equals 4x plus 1. We are almost there. We're going to subtract 1 from both sides, giving us 36 is 4x. That means 9 is x, which means x is 9. It says find the length of each side of this right angle triangle. If x is 9, then that must be 8. And then the other one must be 10. So those are our two sides. So you can't even see those. So 8 and 10 are the sides of each of those sides then of a right angle triangle. Next then, examples of equations with some fractions in them. So let's take a wee look at those. Again, the idea here is to try and get the x on its own. Currently it's divided by 5 and times by 3, so we need to do the opposite of that and then try and tidy up. I'm going to times through everything here by 5. That gives me 3x. If I times 3x over 5 by 5, it means the 5 disappears from the bottom. And I have 45. I'm now going to divide by 3. And it gives me x is 15. Second example, 3 over x equals 7. This is a trickier one. It's not quite as intuitive. But I'm going to times both sides by x. That's the one on the bottom. So times by x. I'm going to get 3 equals 7x. And then I'm going to divide by 7. I'm going to get 3/7 equals x, or x in this case then is 3/7. Final example here. You can do a thing called cross multiplying here. I'm never a fan of it because you need to make sure you can only ever do it across an equals sign. But we have an equation here. I'm just going to try and make both sides. I'm going to times both sides by 15 and we'll see what happens then from there. So if you times a fraction by 15, you only times the top bit of a fraction by 15. If you times the bottom bit, you just get an equivalent fraction. It doesn't make it 15 times bigger. So we're going to times in everything here by 15 and see what we end up with. So times by 15 and times by 15. There are other ways of doing this one. And again, it's sometimes hard to see what your best method is, but let's see what we have. This is going to give me 60x plus 45 all over 5. Do you see I've times the top line then by 15. 75x minus 90 all over 3. The reason I did that is because now I know the fraction should disappear. Again, there's other ways of doing it, and that's okay. 60x divided by 5 should then give me 12x. 45 divided by 5 plus 9. 75x divided by 3, 25x minus 30. Again, if you cross multiply there, you'd get this line straight away, but that's okay. We're not too worried about that. And now, nice and straightforward, take away 12x from both sides. We're going to get 9 equals 13x minus 30. I'm going to add 30 to both sides. 39 equals 13x. And I'm going to divide both sides by 13. I'm going to get 3 equals x, or x equals 3.